So, good evening, everyone. Today's new lecture. Welcome back, everyone. Let's talk about what we did last time and we'll go through what we are doing today. So, last time, guys, we completed ellipse and all the questions and all. And I told you next time is hyperbola. So, in today's lecture, we'll be going through the different forms of hyperbola and some basic our definition. Let us recommend. So, let's start without delaying. Welcome back all. Just a second. Okay, let's see. So today's topic is hyperbola. Introduction and equation of hyperbola. I hope you know what is hyperbola. You must have studied in physics, I think. And hyperbola is a conic whose eccentricity is greater than 1. Now, let me remind you that there were three conics: parabola, ellipse, hyperbola. For parabola, the eccentricity is equals to 1. For ellipse, it is less than 1. And for hyperbola, it is greater than 1. And also, we have discussed eccentricity of circle. For circle, the eccentricity is 0. So here eccentricity is greater than 1. And as you can see here, E equals to 1 for parabola and E less than 1 for ellipse. So next, the equation of hyperbola is. Now, I hope you can relate the symmetry between ellipse and hyperbola. Let me tell you, the all the formulae or all the length of letters rectum, the foci, and everything in hyperbola is the same that was in ellipse. That means you don't need to remember extra things for hyperbola. If you know the formula, everything for ellipse, then we can easily get for hyperbola because it's the same. So here equation also looks almost the same, I would say. Just here it is minus. So what is the standard equation of hyperbola? X square upon a square minus y square upon b square equals to 1. Right? You'll notice something is different here also. Why? These are the only two things where there is a difference from ellipse. Here in ellipse, it was b square equals to a square into e square minus 1. But in ellipse it was 1 minus e square. In hyperbola it is e square minus 1. So these are the only two differences you'll notice in hyperbola. Other all the formulas are same. We'll go through it once again. What is the difference? First the equation and second the eccentricity ka formula. So please remember this. And generally many of students I've seen who get confused between this, like whether to use e square minus 1 or 1 minus e square. So for that I have very simple thing. Just remember the value of eccentricity. The eccentricity for hyperbola is greater than 1. That means e will come before. That means e square minus 1. The eccentricity for ellipse is less than 1. So that means we'll get 1 minus e square. I hope I'm making sense. Let's move forward. Chalo. Just now we did this. A conic is said to be hyperbola if its eccentricity is. See, guys, these types of questions I already told you we do this for just revision purposes so that you stay afresh, your memory stays afresh. So here we already saw, and the state entrance exams, as you may call it, the Karnataka CET and all, they can ask this level of questions. So for hyperbola, eccentricity is greater than 1. So it is option A, right? The equation of hyperbola. What was the difference? X square, this is the equation of ellipse. This is nothing but just, you can say, no solution types, because on the left hand side all the square terms are there. That means it cannot be negative. And this, so we have studied this one. We'll see that this is also a hyperbola, but after some time. So it is option 2. Next topic we can see is nature of the curve. What do you mean by nature of the curve? I hope you remember in ellipse also we did the same thing. Nature of the curve means how the curve looks, or on the xy plane, how does the curve traces the x-axis or y-axis, right? So for that we need to analyze the equations. Let's see how to analyze the equations. Nature of the curve. This is the hyperbola. Now as you can see, x comma y and x comma minus y. If we put in the equation, there is no change in the equation. That means that if I replace y with minus y in the equation does not change. That means the equation is symmetric about x-axis. Y को replace करने से if it doesn't change, it is symmetric about x-axis. And x को replace करने से with minus x, it doesn't change the equation, right? Because it is square. So that means it's symmetric about x-axis. So what we can say that hyperbola is a curve which is symmetric about both the axis, x-axis and y-axis. Such things we can analyze by just seeing the equation. Just the same thing we saw. Next, if we replace x by minus x and y by minus y, as we saw, the equation doesn't change. That means the curve is symmetric about the origin as well. And if the curve is symmetric about origin, then we saw it in the last lecture or in the ellipse also, that midpoint of every chord passes through origin. That means origin is the center of the hyperbola. Here it is, we are finding x-intercepts and y-intercept. If we put y equals to 0, we'll get x-intercept. And what are the x-intercepts? It is plus or minus a. That means the hyperbola cuts the x-axis at 2 points, a comma 0 and minus a comma 0. X-axis is also called as the principal axis, right? Which in hyperbola, in ellipse, if you remember, we used to call it as major axis and minor axis. But in hyperbola, the major axis, or we replace the word major axis with transverse axis, and the word minor axis with conjugate axis. So I hope it is clear. Now, if we try to put x equals to 0, then you can see we'll get y square equal to minus b square. And we know square of a number cannot be negative. That means we do not get real values of y. What does that imply? That y is imaginary. That means the curve never intersects the y-axis. That's what we have given. The curve never intersects the y-axis, but there are points which are 0 comma b and 0 comma minus b, which are known as this is called conjugate axis, as I told you. Unlike ellipse, in hyperbola, the major axis is replaced by transverse axis and the minor axis is replaced by conjugate axis. So I hope you know this. And the distance between point B and B dash is called the length of conjugate axis, which obviously comes to 2b. The focus of the hyperbola. Now you can see in ellipse also the focus was the same. That is AE comma 0. AE comma 0. and this is the second focus, which is minus a comma 0. As I've already told you guys, we'll not be like going into deep for this because the formula for ellipse or the formula for hyperbola are as good as or exactly same as ellipse. The only difference that we saw is that in the eccentricity formula in the equation, right? Apart from that, you will see everything is same as of ellipse. Distance between foci obviously will remain the same as both the focuses are same. Directrix ka equation is also same as you can see, which is x equals to a by e. And what will be the other equation? It will be x equals to minus a by e, right? Same as it was in ellipse. And distance between directrices, obviously it will also not change because the directrix does not change. It will be 2a by e. I hope you can recall all this from ellipse. So you can say it's basically just a revision of ellipse ke formulas. That's why I'm doing it, because you will able to recall all the formulas of the ellipse. Correct? Chalo. What is double ordinate? I hope you know. A chord passing through the point on the hyperbola and perpendicular to the major axis. Here it is transverse axis, or you can say the principal axis. Focal chord, any chord which passes through focus. So there are two focuses, it can pass through either of the foci. So any chord which passes through the focus is called a focal chord. The most important thing, which is lattice rectum. Focal chord which is perpendicular to the transverse axis. That means the principal axis, right? We all know the definition of lattice rectum. Again, I am just revising this all so that you can see and you also get to revise the ellipse because it's same as hyperbola. Till now, we have not seen how hyperbola looks or how the curve looks like on the coordinate axis or on the coordinate plane. We'll see that after defining the terms. Here is a very important thing. As you know, in ellipse, we had two standard forms, right? The equations were the same, just the different forms were based on the values of a and b. One was a greater than b, the other was a less than b. Correct? Similarly, in hyperbola also, we have two standard hyperbolas. One of them which we studied, which was x square upon a square minus y square upon b square equals to 1. The other one is known as the conjugate hyperbola, right? So two standard hyperbolas are the hyperbola itself and the conjugate. Now the equation of conjugate hyperbola is this. Same here, just we put minus 1. The equation of both are same, as you can see. Just on the right hand side, instead of 1, we have minus 1. Chalo. What is the definition? Come on, guys. Let's see. Let's get an answer from you all. Which option do you think it is? Chalo. Chord passing through a point on the hyperbola and perpendicular to the x. Remember, whenever a chord is A chord of hyperbola which passes through either of the foci. So simple, guys. It is the focal chord. Which of the following is true? Yeah, this is important, guys. Let's see. Which are the conjugate hyperbolas? Conjugate hyperbolas we just now saw. No one's in the meeting. Conjugate hyperbolas are x square upon a square minus y square upon b square equal to 1 and the one with negative sign. So I think it is option first. Various forms of hyperbola. I think we already discussed this, guys. The various forms of hyperbola. We have already studied the two forms. Let's see the first form, which is the standard form which we studied till now. So let us see how the form looks, right? So the form looks like this. As you can see, you can say that basically they are two parabolas, but not exactly parabolas. The shape is something like C. But let me tell you, there are two C's, one on the positive x-axis, the other on the negative x. So this is the hyperbola. These curves, both of them, are together called hyperbola. So let's see where the focus and all that lies. So center is 0, comma 0, obviously at origin. You can see here. Next is vertices. What are vertices, guys? Vertices are the points which the curve intersects with the principal axis. That means vertices will be these 2 points. You'll see here a comma 0 and minus a comma 0, a and a dash. These points. Correct. Foci. Foci we know same, but where will the foci lie? Here. The foci will lie here. AE comma 0 and minus AE comma 0. Eccentricity. We already saw the formula for eccentricity, right? Equals to a square into e square minus 1. So from here, we can calculate the value of e. It will be equals to this. Correct? Don't confuse it with ellipse. Ellipse may we have 1 minus e square. So already I told you how to remember it, but still don't get confused. Direct traces. Direct traces are x equals to plus minus ae. Here the direct traces are inside, or you can say towards the origin. That means these are direct traces. This one is x equals to a and this is x equals to minus a. Transverse axis is y equals to 0. Transverse axis means the principal axis, or which we know called it as major axis. So that is x axis, which whose equation is y equals to 0. Conjugate axis is x equals to 0. The second standard hyperbola is basically the conjugate hyperbola, which is x square minus x square upon a square minus y square upon b square equals to minus 1. Now, this can be obtained by rotation of axis. I hope you know rotation of axis, but anyways, it will look like this. Just you rotate by 90 degrees, so it will be a u and a ulta u. All of the things will also be changed with respect to y-axis. Up until now, we were seeing things with respect to x-axis, but for this -1, it will be with respect to y-axis. center is 0 comma 0, you can assume the focus. As I told you, focus, directrix, everything except the equation and the eccentricity remains the same. Vertices are 0 comma b and 0 comma minus b. Right? What will be the foci? Foci again, guys, will be same as that were in ellipse. So ellipse, the foci were 0 comma minus be and 0 comma be. Okay, is there a okay you joined? Is there a network issue at your class, or should we proceed? Should we wait or should we proceed? Yes, network issue. JNV Vedak. I think you all are joining through the screen, right? Directly. Okay, fine. Let's continue. So second equation, let me revise. We were going to the equation of ellipse hyperbola, which is the second equation, x square upon a square minus y square upon b square equals to minus 1. So here the all the things will be same, all the results will be same as that were for ellipse, where b was greater than a, the second standard ellipse. So as you can see here, this is the diagram or the graph, you can say. Eccentricity will be same. Eccentricity how will be the same? It will be a square equals to b square into e square minus 1. From this, we can easily get the value of e. Direct traces, I think you should all guess this before I say, right? So y equals to b. Again, here the direct traces are towards the more towards the origin than the curve. Transverse axis. Transverse axis means principal axis. In this case, the principal axis will be y-axis. That means its equation will be x equals to 0. And conjugate axis is the x-axis, which is y equals to 0. Now here are the results which I have grouped together. As you can see, basically all the standard result you'll see will is the same or are the same as in ellipse. But just I'll give you 2 minutes to go through all this. So 2 minutes, just concentrate 100% on the board or on the screen and see it. What are the differences? The only difference, as I told you, will be in the eccentricity and in the equation. Rest all, length of letters rectum, everything is same. Please, I'll give you 2 minutes to go through it. Come on, guys, fatafat, because we will be doing questions, so you should know all the standard result. Come on. Once over, you can give me a thumbs up. Chalo. Next, I hope you are done. And the minor axis. That means this is the major axis, or you can say the principal axis, and this is the minor axis. All of the equations are same. You can say, please again go through it. I'll give you 2 minutes more, and then we'll proceed further. Come on, guys. Done? Chalo. I hope you have seen all this. So let's proceed to MCQ. Come on. What is the equation of eccentricity? Now, I personally don't remember the formula of eccentricity directly. I remember the formula which was this one. B square equals to A square into E square minus 1. Anytime it just take 2 to 5 seconds for you all to figure out the value of E from here. The value of E square will be 1 plus B square upon A square, which is basically A square plus B square upon A square. So if I want to find the value of E, I'll have to take under root. So as you can see, that is, I think, option first. Correct. Let's see what we have next. The length of lattice rectum. Come on. This is again the standard result, the length of lattice rectum. Please look at the equation carefully. It is a hyperbola with minus 1 sign. So that will be B, which is option number second. Equation of direct traces. This is again the first standard form. Come on. The length of lattice rectum is chalo. This proof I think we have done many times of the same time that we did the proof in ellipse as well as in parabola. So I think you should proceed this yourself. You should prove this yourself. Just let me give you a hint. I'll draw the diagram for you all. So this is the hyperbola. Here is the focus, and this is the length of, sorry, this is the lattice rectum, L dash. So if you know, the focus is AE comma 0, right? And if I assume this distance as L, the coordinates of capital L will be AE comma small l. Now this point L lies on the hyperbola. This point L lies on the hyperbola. That means we have to substitute the values of x and y in the hyperbola from that point and get the value of L. Now I give you some time. I think 2 to 3 minutes will be fine according to me. So by then you should get the formula as 2b square upon a. So let's start. Exactly 2 minutes I'll give. Come on guys. Chalo. I've told you what to do. You just need to do it. Just substitute the value or substitute the point in the equation. Chalo. I hope you're proceeding. Chalo, let's do it. Let's substitute the point. So we'll get a square e square upon a square minus L square upon b square equals to 1. So here a square will get cancelled. Remember, we want the value of L. So I can write L square upon b square is equals to e square minus 1. Now we don't need the value of e, right? So just now we know that b square equals to a square into e square minus 1. So what is e square minus 1? It is b square upon a square. So I can write it here L square upon b square is equals to b square upon a square. Very simple. So I'll get L square as b raised to 4 upon a square implies if I take the square root, then I'll get b square upon a, which is the length, that means value of L. Now we all know the lattice rectum is bisected at focus. That means if this length is L, then this length is also L. Then the length of lattice rectum, which we denote is by LR, lattice rectum will be twice the length of L, which will be 2b square upon A. This is my answer. I hope it is clear. Right, guys? So after this, what we are going to do? We will be doing the standard results. So what are the standard results? Yeah. The standard results that we did the complete equation of hyperbola and the standard hyperbola part. But now we'll be doing standard results part, which the first one, as you all know, we have already done it in ellipse, parabola and ellipse, which is position of the point and equation of the tangent. The position of the point remains the same, guys. If p x1 comma y1 is a point to the hyperbola, right? And the hyperbola on hyperbola, outside hyperbola. Now, what is inside and outside of hyperbola? I think you correctly must have guessed it. If the point P lies on the hyperbola, then S1 equals to 0. If the point P lies inside the hyperbola, then it is S1 greater than 0. It is ulta from ellipse. And if outside, then it is S1 less than 0. Please don't get confused here. Ellipse we had, I think, ulta, right? Here we had S1 less than 0. Here we had S1 greater than 0. So my advice to you is please remember any of the one, and you can remember that the other one is exactly the opposite. I prefer to remember about ellipse. Next, the equation of tangent to the hyperbola. Now this is the same equation of tangent to the hyperbola is t equals to 0. Sorry, t equals to 0. What is t? We replace. Let me remind you, what do we replace? We replace x square with x into x1, where x1, y1 is the point. You can see here, we replace y square with y into y1. So if we replace these two in the equation of hyperbola, we'll get x1 upon a square minus y1 upon b square minus 1 equals to 0. Now, many a times, like you can see in ellipse and hyperbola, majority of the times we'll be using only x square and y, so we'll be needing only x square and y square. But many times we do need 2x. 2x will be replaced by x plus x1. We did this in circle, right? Because equation of circle is every term, x square term, y square term, x term, y term. 2y with y plus y, right? And the constant term remains the same. So this is the equation of tangent. The equation of normal. What is the equation of normal, guys? This one. Now, I don't need you all to remember it, but I do need you all to prove it. I hope you remember how do we prove it in ellipse. Let me go through the steps so you can prove it yourself. Okay, I'll be giving you some time. First step, get the slope of tangent. This is the equation of tangent. How to get slope of tangent? You all know. Second step, use slope point form. Khatam. Point is given already. X1 comma y1. We got the slope of tangent from here. Sorry, how do you get a slope of normal? Normal and tangents are perpendicular to each other. That means if slope of tangent is 2, slope of normal will be negative reciprocal, minus 1 by 2. So we got the slope of tangent from here. Get the slope of normal by negative reciprocal. Point is already there. Use slope point form. Come on. I'm giving you guys 2 minutes only. I think that is fine enough for you all to prove that the equation of normal is this. Again, I'm repeating. Get the slope of tangent from here. Get the slope of normal. Use slope point. Come on, guys. You should practice all this here. I'm not very interested in the derivation and all because it never comes. I am doing this only because it's important in questions. There will be questions where you will be needing the manipulation you do here, right? That we'll see how the question comes. Come on, 2 minutes, guys. Let's see. I hope you made some progress. What did you all get the slope of tangent as? Chalo. Did you all use the slope point form? Sure. I hope you got it. Next thing that we are going to do is, the condition for tangency, right? The condition for tangents. Now, how do we get the condition for tangency? I hope you remember it, right? From ellipse. What do we did? We compared the coefficients of two same equations. That means this is the equation of tangent which they have given. I will write the equation of tangent which I know, and then both the equations represents the same tangent. That means both are the same equations. That means I can compare their coefficients. This is very, very, very important, guys, because many in almost consecutive years they have asked the same question in JE based on this concept. Many simple questions will be solved by using just this concept. Write the equation of a curve in two different ways and compare the coefficient. They have given this. So we know that equation of tangent is at point x1 comma y1 is x1 upon a square minus y1 upon b square is equals to 1. And the given equation is minus mx plus y is equals to C. So these both represent the same curve. So we can compare the coefficients. What is the coefficient of x here? X1 upon a square. What is the coefficient of x here? Minus m is equals to coefficient of y here minus y1 upon b square. Coefficient of y here is 1, which is equals to 1 upon c. So from this also we get the point of contact of tangent, right? So if we equate this and equate this, we'll get the point of contact, which is x1 comma y1, or point of tangency. What will be x1 minus a square m upon c? And you'll notice it's the same as we got in ellipse. And this is minus b square by c. Right? We got a separate result here, but we want to prove this. So how do we prove this? We get the coordinates of this point, and these coordinates must satisfy the equation of hyperbola because they lie on the hyperbola. So let us substitute x1 and y1 here. So x1 की जगह पे ये आएगा, right? And y1 की जगह पे we'll substitute this. So x square upon a square. That means we'll get minus a. So it'll become a raised to 4 m square upon c square. B raised to 4 upon c square. B square is already there, equals to 1. So I think a square, and here we can cancel out the power 2, same for b square. So we'll get a square m square minus b square upon c square equals to 1. So if we cross multiply, I think we'll get a result. A square m square minus b square equals to c square. Right? The same result, c square equals to a square m square minus b square. So from this, you see, we derived two results. First was the condition of tangency, and second was the point of contact. Right? So I think we should end it here. Time is already up. Thank you all for joining. I hope you remember hyperbola. This was the last thing we did with its condition of tangent. On the next time, we'll see other standard result, pair of tangents, chord of contact, and lastly the parametric form. So I think we'll be able, there are some extra part, asymptotes, I think you have heard it. So we'll be doing that in hyperbola, which was not in ellipse. What are the results remaining, guys? Chord of contact, chord with given middle point, pair of tangents, auxiliary circle, and director circle, and lastly the parametric. So these things will be covering in the next lecture. So thank you all, guys. Thank you for joining. Bye bye everyone. Take care.